When it comes to evaluating students' understanding of AI concepts, limitations, and potential biases, it's helpful to mix things up with a variety of assessment methods. Start by asking some conceptual questions. Invite students to define artificial intelligence in their own words, distinguish between narrow and general AI, and explain foundational techniques like machine learning, neural networks, or natural language processing. This not only checks their grasp of the basics, but also encourages them to articulate complex ideas simply. To take things further, bring in real world scenarios where AI is at play. Think facial recognition systems or recommendation algorithms. Have students break down these examples, identifying the specific AI components involved, how they function, and what outcomes might result. This approach helps bridge the gap between theory and practice, showing students how abstract concepts come to life in everyday technology. It's also crucial to have open discussions about AI's current limitations. Ask students to consider issues like dependency on large data sets, lack of common sense reasoning, difficulties with transfer learning, and the ongoing challenge of making AI decisions explainable. These conversations encourage critical thinking and remind students that despite all the hype, AI still has plenty of hurdles to overcome. Bias is another important topic. Present students with examples of AI systems that have demonstrated bias, such as hiring algorithms that inadvertently favor one gender or race over another. Challenge them to analyze where these biases come from, how they show up in the system's outputs, and what strategies might help mitigate them. This not only raises awareness, but also empowers students to think about building fairer systems in the future. Encourage students to reflect on the broader ethical implications of AI. Prompt them to consider privacy concerns, questions of accountability, and the potential societal impacts of deploying AI technologies at scale. Reflection exercises like these push students to look beyond the technical details and think about the real world consequences of their work. Finally, give students the chance to dive deep with a project or case study. Assign them to research a specific AI application, asking them to present its underlying methods, discuss any technical or ethical limitations, and highlight challenges related to bias. This kind of hands-on work helps solidify their understanding and gives them practical experience in analyzing AI systems holistically. By weaving together these varied approaches, you can get a well-rounded sense of each student's understanding, not just of the nuts and bolts of AI, but also of its limitations and the critical issues that come with applying it in the real world.